For the Japanese soldier, victory was to be carved from the earth with a shovel and sheer willpower. 1,000 men, toiling for months, could raise a fortress from the coral and mud. But on the horizon, a new sound carried on the wind. Not the thunder of naval guns, but the growl of a diesel engine. A single American machine, driven by a single man, could erase a month of their labor in a single afternoon. How can an empire built on spirit fight an enemy that builds its victory with steel? The war in the Pacific was a conflict defined not by front lines, but by a vast, unforgiving ocean punctuated by tiny, fiercely contested islands. It was a war of logistics, a brutal equation of distance and time. Each island captured was a stepping stone, a potential refueling station, a repair depot, and most critically, a platform for air power. An airfield was a dagger pointed at the heart of the enemy's next position, a fixed point of control in a fluid theater of war. From these freshly carved runways, fighters could provide air cover for the fleet. Reconnaissance planes could map the enemy's next move, and transport aircraft could ferry in vital supplies and reinforcements. And ultimately, they would become the launching pads for the long-range strategic bombers like the B-29 Superfortress that would bring the war to Japan's doorstep. The nation that could build these bases fastest would control the tempo of the entire campaign, forcing its enemy to react, to retreat, to surrender ground. It was a race, not of infantrymen or battleships, but of engineers. For the Empire of Japan, this race was run on the backs of men. Their construction units, the Setsu Atai, were a testament to a national philosophy of human endurance. Often composed of conscripted Korean and Chinese laborers alongside Japanese engineers with minimal equipment, they were armed with the most basic of tools: picks to shatter the stubborn coral, shovels to heave the sun-baked earth, and hand-woven baskets to carry it away, load by painful, back-breaking load. Theirs was a philosophy born of industrial necessity and steeped in the martial tradition of Seishin, the belief that the power of spirit and will could triumph over any material deficit. Japan's industrial base, a fraction of America's, had made a critical strategic gamble before the war began. It had focused its limited resources on producing exquisite combat assets, the world's best carrier aircraft, formidable battleships, and the legendary Long Lance torpedo. The logistics, the construction, the support infrastructure needed to sustain a long war were considered secondary. The plan was for a swift, decisive conflict. Consequently, heavy machinery like bulldozers, graders, and rock crushers were luxuries the military could seldom afford for what they viewed as static, defensive work. They would rely on manpower. The daily reality for a member of a Setsuatai unit was a grueling, monotonous cycle of toil. From sunrise to sunset, the rhythmic scrape of shovels and the sharp crack of picks against rock was the only sound. Progress was measured in feet, not miles. An airfield, a task that demanded the movement of hundreds of thousands of cubic yards of earth, became a project spanning many months, sometimes even years. The story of Henderson Field on Guadalcanal is the perfect illustration of this philosophy in action. For months, Japanese engineers and laborers toiled to carve a runway from the dense jungle, a monumental undertaking intended to secure their dominance in the Solomon Islands. Yet, when the 1st Marine Division stormed ashore in August of 1942, they found the airfield dangerously incomplete. It was a symbol not of Japanese ambition, but of the fatal slowness of their method. The war was moving faster than their shovels could. While they measured progress in seasons, their opponent was about to start measuring it in weeks and soon in days. The conflict in the Pacific was about to become a war of competing industrial cultures, and the Japanese doctrine of human will was about to collide with a force that had harnessed the raw power of the machine. A new kind of American warrior was coming ashore, a man whose primary weapon wasn't a rifle, but a lever, and whose battlefield was the very earth itself. In the wake of the devastating attack on Pearl Harbor in December of 1941, the United States faced a daunting logistical challenge across the Pacific. To fight a war across thousands of miles of ocean, it needed bases. But the civilian construction contractors who had previously built facilities on islands like Guam and Wake Island were just that, civilians. They were not trained, armed, or organized to work on an active battlefield. When war erupted, they were either captured or evacuated, leaving a critical void. The American war machine needed a new kind of unit, one that could operate under fire, a force that could build a port while dodging mortars and lay down a runway while fending off enemy patrols. The answer was a uniquely American solution, born from the nation's deep well of industrial know-how and pragmatism. The Naval Construction Battalions, quickly nicknamed the Seabees from the abbreviation CB, their motto captured their dual nature perfectly. We build, we fight. They were a breed apart from the fresh-faced teenagers filling the ranks of the Marine Corps. The average age of a Seabee was 37. These were not boys learning a trade. They were masters of their craft who had been recruited directly from the civilian construction industry. They were carpenters, electricians, heavy equipment operators, draftsmen, and mechanics who had spent their entire adult lives building the roads, bridges, and skyscrapers of America. The Navy offered them a unique proposition: join the war effort not as infantrymen, but as the experts they already were. They underwent military training, learning to handle rifles, machine guns, and anti-aircraft artillery. But their real value lay in the skills they brought with them. This experience gave them an unparalleled ability to improvise, to solve complex engineering problems with limited resources, and to get the job done under the most extreme pressure. They understood the land, the materials, and the machinery with an intuition born of 1,000 civilian projects. Their arrival on a newly captured island was a spectacle of industrial might, a stark contrast to the painstaking manual labor of the Japanese. Enormous landing ship, tanks or LSTs would push their bows onto the beach, their front rams slamming down not to disgorge columns of infantry, but to unleash a torrent of mechanical power. Out would roll the machines that had tamed the American continent: cranes, graders, power generators, and welding shops on wheels. And at the forefront of this metallic tide was the undisputed king of the construction battlefield, the Bulldozer. Specifically, the Caterpillar D8, a 12-ton beast of yellow steel and diesel muscle. The wartime 8R series model was a marvel of robust engineering, a simple, powerful tool designed for the harshest conditions. To the Japanese soldiers hiding in the jungle, watching from their meticulously hand-dug positions, the sight and sound of these machines must have been utterly demoralizing. The impact was immediate and overwhelming. Where it took a company of Japanese laborers an entire day of back-breaking work to clear a small patch of jungle, a single Seabee aboard a D8 could do the same in less than an hour, leaving behind a perfectly graded surface. The machine didn't just move Earth, it reshaped the very calculus of war. The rhythmic growl of its engine became the soundtrack of American expansion across the Pacific. With these tools, the Seabees could accomplish in days what had taken their adversaries months. They could land on a beach and within 72 hours have a primitive, fighter strip operational. Within a few weeks, that strip would be a fully fledged air base with paved runways, maintenance hangars, fuel depots, and roads connecting it all to a newly dredged port. This wasn't just construction. It was a weaponized industrial revolution deployed at the front lines. The productivity gap wasn't just a number. It was a chasm that Japan had no way of crossing. The sheer scale of the productivity gap is difficult to comprehend, but military planners quantified it in stark, unambiguous terms. A single Seabee operator, skilled at coaxing the maximum effort from his Caterpillar D8, could move a volume of earth in 1 hour that would demand the labor of approximately 300 Japanese soldiers working with hand tools for an entire day. It was a ratio of almost astronomical proportions, a force multiplier that fundamentally altered the strategic landscape. This was not a linear advantage. It was an exponential one. It meant that for every day the Japanese spent toiling, the Americans could achieve the equivalent of a year's worth of work. It was a war of attrition, where one side was fighting with shovels and the other with a landslide. This disparity was not just a matter of convenience. It was a core component of American combat strategy, a concept known as island hopping. The Americans could bypass heavily fortified Japanese strongholds, seize a lightly defended island nearby, and then, with breathtaking speed, build an airfield on it. From this new base, they could bomb the bypassed fortress into irrelevance, cutting its supply lines and leaving it to wither on the vine. This strategy was only possible because of the Seabees and their machinery. Islands like Tarawa, Saipan, and Guam became legendary not just for the ferocity of the marine assaults, but for the engineering miracles that followed. On Tinian, for instance, the Seabees constructed what would become the largest air base in the world, with 6 11,000-foot runways. It was from these very runways, paved and leveled by American bulldozers, that the Enola Gay and Boxcar would later take off on their atomic missions to Hiroshima and Nagasaki. The B-29 Superfortress, the pinnacle of American aeronautical engineering, was a weapon that required immense logistical support. It needed long, perfectly graded runways, massive fuel farms, and extensive maintenance facilities. These were demands that Japan's manual construction methods could never have met in a forward combat zone. The American bomber offensive, which systematically dismantled Japan's industrial capacity in the final year of the war, was launched from airfields that were, in essence, prefabricated in the factories of the American Midwest and assembled on Pacific Islands by the Seabees. The Japanese High Command was not blind to this reality, but they were trapped by a series of cascading failures. Their pre-war industrial planning had been a catastrophic miscalculation. By prioritizing short-term offensive weapons, they had neglected the less glamorous, but arguably more critical, tools of logistical endurance. They simply did not have the factories to mass-produce heavy construction equipment on the scale required. Even if they had possessed a handful of such machines, getting them to the front lines would have been a near impossible task. By 1943, the United States submarine fleet was systematically strangling Japan's maritime supply lines. The Silent Service waged a devastatingly effective campaign against Japanese merchant shipping, sinking the vessels that carried troops, ammunition, food, and what little industrial equipment they had. A bulldozer sitting on a factory floor in Osaka was useless if it could never reach the beleaguered garrison on Okinawa. This left local Japanese commanders in an impossible position. They knew the Americans were coming. They had months, in some cases, to prepare their defenses. But without mechanical assistance, every pillbox, every bunker, every anti-tank ditch, had to be dug by hand. The volcanic rock and dense coral of the Pacific Islands were unforgiving materials. Progress was agonizingly slow. On island after island, American invasion forces would land to find Japanese defensive networks only partially completed. The fortifications that were finished were formidable, but they were often isolated islands of resistance in a sea of unfinished trenches and gun pits. The Japanese soldier, armed with his rifle and his indomitable spirit, was being let down by a strategic failure of industrial vision. He was being asked to hold back a tidal wave of steel with a wall of sand, and the tide was coming in faster than he could build. The sound of the American bulldozer wasn't just the sound of construction. It was the sound of the enemy's timetable, accelerating beyond any hope of a response. Nowhere was the clash of these two philosophies, mechanized speed versus manual endurance, more vividly demonstrated than in a small, almost forgotten skirmish in the Treasury Islands in late 1943. The operation was a sideshow to the larger struggles in the Solomons, an effort to secure an anchorage and a site for a new radar station. On October 27th, elements of the New Zealand 8th Infantry Brigade and American Seabees landed on Sterling Island. The initial fighting was sharp, but the Allied forces quickly established a beachhead and began pushing inland. The advance, however, soon ground to a halt. A single, well-concealed Japanese pillbox, built from coconut logs and reinforced with coral and steel, had the entire sector pinned down. Its machine guns swept the approach with deadly accurate fire, and it was impervious to grenades and small arms. Every attempt to outflank it was met with a hail of bullets. The infantry was stuck. Ordinarily, this would have called for a heavy mortar barrage or a risky frontal assault by a flamethrower team. But on this beach, a different kind of asset was available. His name was Aurelio Tassoni, a machinist's mate in the 87th Naval Construction Battalion. Tassoni was not a professional infantryman. He was a construction worker from Massachusetts, a man more accustomed to building foundations than storming them. But his weapon was a Caterpillar D8 bulldozer. Hearing the desperate calls from the front, an idea began to form. He lowered the dozer's massive steel blade, creating an improvised 12-ton shield. With the throttle wide open and the diesel engine roaring in protest, he began to drive his machine directly towards the Japanese bunker. Bullets sparked and ricocheted harmlessly off the thick blade as he rumbled across the shell-pocked ground. The Japanese gunners, who had held dozens of infantrymen at bay, could only watch in disbelief as this unstoppable steel monster bore down on them. Tassoni didn't stop. He pushed his bulldozer right up to the firing slit of the pillbox, the heavy blade effectively blinding the crew inside. Then, using the machine's powerful hydraulics, he began to systematically raise and drop the blade onto the structure, smashing the coconut logs and coral as if they were kindling. Still not satisfied, he then used the immense torque of the D8's tracks to pivot and grind the remains of the bunker into the soft earth, burying the occupants and silencing the gun for good. In a matter of minutes, a single Seabee had accomplished what an entire infantry platoon had failed to do in hours. The advance resumed. Tassoni's impromptu charge was more than just a moment of battlefield ingenuity. It was a perfect microcosm of the Pacific War. It was the physical embodiment of America's industrial might being brought to bear at the tactical level. Here was a machine of construction, a tool of creation, being used as an instrument of destruction. This event, though small in the grand scheme of the war, was not an isolated one. Throughout the Pacific, the bulldozer became an ad hoc combat vehicle. Seabees used them to clear paths through dense jungle under fire, to fill in anti-tank ditches while being shelled, and to construct protective earthen berms for artillery positions in the midst of battle. They became improvised minesweepers, their heavy blades detonating buried explosives ahead of the main force. The men who operated them were a special kind of brave. They sat exposed in an open cab, a large and slow-moving target, protected only by the roar of their engine and the thickness of their blade. Yet they did their jobs with a calm professionalism that astounded the combat troops they supported. They were builders who had learned to fight, and in doing so, they blurred the line between logistics and combat. They proved that the war in the Pacific would be won not just by the men who could take the ground, but by the men who could master it. The strategic implications of this construction supremacy echoed all the way to the highest levels of command. Fleet Admiral William "Bull" Halsey, the famously aggressive commander of the U.S. Third Fleet in the South Pacific, was a man who understood naval power better than almost anyone. He commanded fleets of aircraft carriers, battleships, and cruisers, the very symbols of military might. Yet, when asked after the war to list the most important instruments that led to victory in the Pacific, his answer was surprising. First, he named the submarine, which had crippled Japan's merchant marine. Second was radar, the electronic eyes of the fleet. Third came the aircraft, which had revolutionized naval combat. And fourth, on his list, ahead of every single surface warship under his command, ahead of the battleships, the cruisers, and the destroyers, was the Bulldozer. This was a stunning admission from a blue-water admiral, a testament to the fundamental truth that the Seabees had demonstrated on island after island. Without bases, the fleet could not project power. Without airfields, the planes were grounded. The Bulldozer was the linchpin, the humble, earth-moving machine that made everything else possible. This recognition was not merely retrospective. It shaped battlefield decisions in real time. The ability to rapidly construct and repair infrastructure gave American commanders a flexibility their Japanese counterparts could only dream of. When a Japanese bombing raid cratered a vital runway on Guadalcanal, Seabees and their bulldozers would swarm the site, often while the raid was still in progress. They would fill the craters, grade the surface, and have the runway operational again in a matter of hours. For the Japanese, such damage would have taken days, if not weeks, of manual labor to repair, effectively taking the airfield out of the fight. This rapid recovery capability meant that American air power was far more resilient, able to absorb a punch and get back into the fight almost immediately. It turned Japanese air raids from potentially crippling blows into temporary annoyances. The enemy was fighting an opponent that could regenerate, that could heal its wounds with a speed that defied all conventional military wisdom. This advantage compounded over time. With each island captured and developed, the logistical chain grew stronger and the reach of American power extended further. The new bases became staging points for the next invasion, creating a relentless, self-sustaining momentum. The Japanese were caught in a strategic trap. Their only hope was to make each island fortress so costly to take that the American public would lose the will to continue the fight. This was the logic behind the brutal, no-surrender defense of islands like Peleliu and Iwo Jima. But even here, the Bulldozer played a crucial role in the American victory. On Iwo Jima, the volcanic ash that made up the island's surface was a nightmare for vehicles, bogging down tanks and trucks. Seabees, working under horrific fire, used their bulldozers to clear paths off the beaches, allowing men and materiel to move inland. They carved roads up the slopes of Mount Suribachi and built causeways over anti-tank ditches, enabling the Marines to press their attack against an incredibly determined defender. The war in the Pacific was thus a story of two competing clocks. The Japanese clock was slow, methodical, and powered by human muscle. It was the clock of a pre-industrial age where great works took seasons to complete. The American clock was fast, loud, and powered by the internal combustion engine. It ticked to the rhythm of pistons and hydraulics, a clock that measured progress in hours and days. Every airfield the Seabees completed was another turn of the screw, tightening the blockade and bringing the war closer to Japan. The Japanese soldier, waiting in his hand-dug bunker, could only listen as the growl of the bulldozers grew louder, a mechanical heartbeat counting down the final moments of his empire. He was being defeated, not just by an army, but by a mobile factory, an assembly line of conquest that was relentlessly paving a road to Tokyo. The psychological impact of this industrial disparity on the individual Japanese soldier was profound and corrosive. The Japanese military had cultivated a powerful ethos centered on the superiority of the human spirit. Recruits were indoctrinated with the belief that their loyalty to the emperor, their superior discipline, and their willingness to die would grant them victory over a decadent and materially obsessed American enemy. Propaganda portrayed Americans as soft, reliant on machines, and unwilling to engage in the hardships of close combat. For the soldier on the front lines, however, the reality he witnessed was a jarring contradiction to everything he had been taught. He saw an enemy that was not only willing to fight with savage ferocity, but one that arrived with an overwhelming arsenal of mechanical servants that did the work of entire battalions. Imagine the perspective of a Japanese engineer who had just spent 6 months of grueling labor with his unit, hacking a crude airstrip from the jungle. They had suffered from malaria, malnutrition, and the constant draining humidity. They had moved thousands of tons of earth by hand, their bodies aching and their spirits worn thin. Their achievement, a bumpy, often muddy runway, was a source of immense pride, a testament to their sacrifice. Then, in a matter of days, the Americans would land, and from his hiding place in the hills, this engineer would watch a fleet of yellow machines descend upon a nearby valley. He would hear the unending roar of their engines, a sound that blotted out the noises of the jungle. He would see them fell ancient trees in minutes, trees that had taken his men a full day to chop down. He would watch as they leveled hills and filled ravines, carving a perfectly flat, 10,000-foot runway from the virgin landscape in less than 3 weeks. What must that have felt like? It was a display of power so immense, so effortless, that it transcended the normal calculus of warfare. It wasn't just a material advantage, it felt like a force of nature. It was a direct, undeniable refutation of the idea that spirit alone could win the war. The sight of a single American sailor sitting comfortably in the seat of his bulldozer and calmly smoking a cigarette while doing the work of 1,000 men was more demoralizing than a banzai charge cut down by machine gun fire. A battlefield defeat could be rationalized. The enemy was lucky. The tactics were flawed. But this was a demonstration of a fundamental gap in capability, a sign that the very foundations of their nation's power were built on a fatal miscalculation. It suggested that no amount of individual courage or sacrifice could bridge the chasm that separated their hand-tool technology from America's industrial might. This creeping sense of futility began to seep into the diaries and letters of Japanese soldiers. They wrote of the devil machines and the endless noise of construction that gave them no rest, even miles from the front line. The sound of the bulldozer became a constant reminder of the enemy's progress, a portent of the bombers and artillery that would inevitably follow. This psychological warfare was perhaps unintentional, but it was incredibly effective. It eroded morale, planting a seed of doubt that the war was not just unwinnable, but that their entire effort was a futile struggle against an opponent operating on a different plane of existence. The American Seabee, in his dusty work clothes and steel helmet, became an unlikely symbol of this new form of warfare. He was the harbinger of an industrial storm, and his unassuming bulldozer was the machine that cleared the path for the inevitable destruction to come. He wasn't just building a base, he was deconstructing the enemy's will to fight, 1 cubic yard of earth at a time. The legacy of the Seabees and their machinery is written across the Pacific, etched into the coral atolls and volcanic islands that were once the scene of such bitter conflict. Many of the modern airports on islands like Guam, Saipan, and parts of the Solomon Islands began as the primitive fighter strips and massive bomber bases carved out by the naval construction battalions. The roads that connect villages, the deep-water ports that service modern trade, many of these essential pieces of infrastructure have their origins in the wartime projects of 1943 and 1944. The Seabees didn't just build temporary military installations. They laid the groundwork for the post-war world in the Pacific. They were the pioneers of a new era, using their bulldozers not just to win a war, but to reshape entire landscapes for the generations that would follow. Their work was a testament to the idea that construction could be as decisive a military act as destruction. The story of the bulldozer in the Pacific is more than just a tale of technological superiority. It is a story about the character of the nations involved. Japan, a nation with a proud martial history, put its faith in the warrior spirit, in the unyielding will of the individual soldier. America, a nation of inventors, entrepreneurs, and builders, put its faith in its industrial capacity, in its ability to mass-produce not just weapons, but the tools that would empower its fighting men. The Seabee, the 37-year-old civilian expert in a military uniform, was the perfect embodiment of this American approach. He represented a system that valued practical skill and professional experience as highly as traditional military virtues. He was proof that a master mechanic or a skilled carpenter could be as vital to the war effort as a decorated infantry captain. This pragmatic approach allowed the United States to leverage its greatest national strength, its civilian industrial base, and apply it directly to the battlefield. Furthermore, the logistical chain that brought these bulldozers to the front lines was a miracle of its own. Every Caterpillar D8 that landed on a Pacific beach represented a vast, complex network of production and transportation. It began in a factory in Peoria, Illinois, where American workers, many of them women, assembled the machines on a 24-hour schedule. From there, it traveled by rail to a port on the West Coast, where it was loaded onto a Liberty ship. That ship then had to survive a perilous journey across thousands of miles of ocean, hunted by Japanese submarines, before finally delivering its precious cargo to a forward base. This entire process, from factory floor to front line, was a symbol of America's ability to organize and execute logistical operations on a global scale. Japan's inability to match this capability, its failure to either produce its own machines or to protect the ships that could carry them, was as critical a factor in its defeat as any single battle. The war was won not just on the beaches, but in the factories and shipyards half a world away. In the final analysis, the humble bulldozer stands as one of the most significant, yet unsung heroes of the Pacific War. It did not fire a shell or drop a bomb, but without it the shells could not have been delivered, and the bombs could not have been loaded. It was the workhorse that prepared the battlefield, the enabler of victory. It transformed impenetrable jungles into strategic assets and remote atolls into unsinkable aircraft carriers. The story of Aurelio Tassoni, the Seabee who used his machine as a tank, is the perfect metaphor for its role in the larger conflict. It was a tool of peace, of construction and progress, forced into a role of violent confrontation. And in that role, it proved to be as decisive as any weapon in the American arsenal. It demonstrated that in modern industrial warfare, the power to build is the ultimate power to win. The organizational genius behind the Seabees was a critical element of their success, a factor often overlooked in the dramatic tales of combat engineering. Before 1941, the Navy's construction projects were handled by civilian firms under government contracts. This system was slow, bureaucratic, and wholly unsuited for a global conflict. The creation of the Seabees brought construction under direct military command, streamlining the entire process. A theater commander like Halsey or Nimitz could now identify a strategic need, say, a new long-range bomber base on Saipan, and the entire chain of command, from logistics planning in Washington, D.C., to the individual bulldozer operator on the ground, was integrated into a single, cohesive military operation. This unity of command was a tremendous advantage. It meant that resources could be allocated, priorities could be set, and plans could be executed with a speed and efficiency that a civilian-led system could never achieve. The training and composition of a naval construction battalion were also meticulously designed for maximum effectiveness. Each battalion was a self-contained, modular unit of about 1,100 men, containing all the skills necessary to build a small city from scratch. It was divided into companies, each with a specific specialty. One company might consist of heavy equipment operators, the bulldozer, crane, and grader specialists. Another would be made up of carpenters and steel workers, responsible for erecting buildings and hangars. A third would be the electricians and utility specialists, tasked with setting up power grids, water purification systems, and communication lines. This specialization allowed for a highly efficient division of labor. When a battalion landed, each company knew its mission. While the dozer operators cleared and leveled the ground for an airfield, the carpenters could simultaneously begin assembling prefabricated structures for barracks and command posts. It was a symphony of construction, with multiple complex operations proceeding in parallel, all coordinated by experienced civil engineers who served as the battalion's officers. This structure also made the Seabees incredibly adaptable. While one battalion might be tasked with building a massive, permanent air base like the one on Tinian, a smaller detachment could be sent to a remote island to construct a simple radar station or a PT boat base. Their modular nature meant they could be tailored to the specific needs of any given operation. This flexibility was invaluable in the sprawling, ever-changing Pacific theater. Moreover, their inherent repair and maintenance capabilities were a massive force multiplier. The Seabees didn't just operate the equipment, they fixed it. Every battalion had a contingent of expert mechanics who could strip down a diesel engine in the middle of a jungle, weld a cracked bulldozer blade, or fabricate a replacement part from scrap metal. This ability to maintain their equipment in the harshest forward conditions meant that American industrial power was not a one-shot advantage. It was a persistent regenerative capability that could be sustained thousands of miles from the nearest naval shipyard or supply depot. Contrast this with the Japanese Setsuatai. These units were often formed ad hoc, with little standardized training or equipment. Their leadership was frequently drawn from infantry or artillery officers who had little to no engineering experience. They were seen not as a specialized technical branch, but as a pool of manual labor. This lack of a professional engineering corps within the Japanese military was a critical weakness. They lacked the institutional knowledge to plan and execute large-scale construction projects efficiently. Their efforts were often plagued by poor planning, inefficient use of manpower, and an inability to adapt to unforeseen challenges. While the American Seabees were a finely tuned machine of professional builders, the Japanese construction units were often little more than armed labor gangs. This disparity in human capital, in skills, training, and organization, was just as significant as the disparity in mechanical horsepower. The bulldozer was a powerful tool, but it was the skilled hands of the Seabees that turned it into a war-winning weapon. The raw materials of war, coral, rock, and mud, were the same for both sides, but the American approach to handling them represented a revolution in military engineering. The Seabees brought with them a system, a methodology of construction refined in the competitive commercial projects of peacetime America. It began with surveying. Teams of draftsmen and civil engineers would go ashore, often with the first wave of Marines, to map the terrain and identify the best locations for runways and port facilities. They used modern transits and levels, allowing them to plot out a perfectly graded airfield with mathematical precision before the first bulldozer even started its engine. This scientific approach ensured that the construction effort was focused and efficient, avoiding the costly trial-and-error methods that often hampered Japanese projects. They were not just moving dirt, they were reshaping the island according to a detailed blueprint. Following the surveyors came the masters of earth moving. The bulldozer was the star, but it was supported by a full cast of specialized machinery. Power shovels and dragline cranes could excavate massive quantities of earth for foundations or dredge harbor channels. Motor graders, with their long, angled blades, could then sculpt the rough-hewn surface left by the bulldozers into a perfectly smooth plane, essential for the delicate landing gear of heavy bombers. Armies of dump trucks would ferry rock and coral from quarries, often established on-site with portable rock crushers, to lay the foundation for all-weather runways. The Seabees even brought mobile asphalt and concrete mixing plants, allowing them to pave surfaces that could withstand the torrential tropical rains and the immense weight of a fully loaded B-29. This was not just construction. It was an entire industrial ecosystem, transported across an ocean and reassembled on a hostile shore. This system was also remarkably resourceful. The Seabees were masters of improvisation, legendary for their ability to build whatever was needed from whatever was at hand. Their most famous creation was the pontoon. These were large, hollow steel boxes that could be locked together like building blocks to create an astonishing variety of structures. They could be assembled into causeways to bridge reefs, allowing trucks and tanks to drive directly from transport ships to the shore. They could be formed into floating piers and dry docks for repairing damaged ships. They could even be stacked and welded together to create storage tanks or defensive blockhouses. Another iconic Seabee innovation was Marston matting, perforated steel planks that could be interlocked to rapidly create a durable, all-weather surface for an airfield. A runway that would take weeks to pave with concrete could be laid with Marson matting in a matter of days, allowing aircraft to operate almost immediately after the ground was leveled. These technologies and techniques gave American forces a decisive operational advantage. While Japanese airfields were often unusable after a heavy rain turned them into quagmires, Seabee-built fields with their crushed coral bases and Marston matting surfaces could continue flight operations in almost any weather. This reliability was a crucial factor in maintaining a high tempo of air attacks. The Japanese forces were not just outproduced, they were out-engineered. Their reliance on manual labor meant they were fundamentally limited by the physical endurance of their men. The Americans, by contrast, were limited only by the amount of fuel they could pump and the number of hours in a day. The contest in the Pacific was, in many ways, a battle between muscle and mechanics, between an agricultural age approach to engineering and an industrial age one. The outcome was never truly in doubt. Every new piece of equipment that rumbled off a landing craft was another nail in the coffin of an empire that had fatally underestimated the power of the machine. The Pacific Campaign can be visualized as a series of great leaps, each one enabled by the creation of a new forward base. The first critical hub was Henderson Field on Guadalcanal. Captured from the Japanese while still incomplete, it was the Seabees who transformed it into the unsinkable aircraft carrier that would ultimately secure the Solomon Islands. It was here, in the mud and heat of 1942 and 1943, that the pattern was set. The Marines would take the ground, and the Seabees would immediately follow, working around the clock under constant threat of air raids and naval bombardment, to expand and improve the vital airfield. Every day the field was operational was another day that American fighters could intercept Japanese bombers, another day that dive bombers could attack Japanese warships. Henderson Field was not just a piece of territory, it was the fulcrum upon which the entire Solomon Islands campaign pivoted, and it was held together by the bulldozers and graders of the 6th Naval Construction Battalion. From the Solomons, the island-hopping campaign accelerated. The next great leap was into the Central Pacific, targeting the Marshall and Mariana Islands. The strategic prize here was immense. Islands like Saipan, Tinian, and Guam were within long-range bombing distance of the Japanese home islands. Capturing them and building the necessary air bases was the absolute top priority for the American High Command. The battles for these islands were among the most brutal of the war, but once the fighting subsided, the scale and speed of the Seabee construction effort were staggering. On Saipan, they repaired and expanded the existing Japanese airfield, Isley Field, and then built an entirely new one, Kobler Field, dedicated to the B-29 superfortress. But it was on the neighboring island of Tinian that their work reached its zenith. On Tinian, the Seabees undertook the most ambitious construction project of the entire war. In just a few months, they transformed the island's sugarcane fields into the largest and busiest airport in the world. They built 4 massive 10,000-foot runways, perfectly parallel and spaced for maximum operational efficiency. They constructed miles of taxiways and hardstands capable of parking hundreds of B-29 bombers. They erected enormous maintenance depots, vast fuel storage farms, and barracks for tens of thousands of airmen. It was a city dedicated to the single purpose of strategic bombing, and it was built from scratch in the middle of the Pacific Ocean in record time. This monumental achievement was the direct result of the lessons learned at Guadalcanal and across the Pacific. It was the culmination of 2 years of mastering the art of forward-base construction. It was from Tinian's North Field that the final phase of the war would be launched, a devastating air offensive that would bring the conflict to its fiery conclusion. The story was repeated on Iwo Jima and Okinawa. On Iwo Jima, the island was declared secure on March 26, 1945, but even before that, on March 4th, a crippled B-29 returning from a raid on Tokyo made an emergency landing on the southern airfield, which was still under construction and under enemy fire. This single event justified the immense cost in lives to take the island. By the end of the war, over 2,400 superfortresses would make emergency landings on Iwo Jima, saving the lives of nearly 27,000 airmen. The Seabees had built a lifeboat in the middle of the ocean. On Okinawa, the final major battle, they performed a similar miracle, repairing captured Japanese airfields and building new ones under some of the most intense kamikaze attacks of the war. Each new base was a tightening of the noose, a closing of the ring around Japan. The map of the Pacific in 1945, dotted with American air bases, is a map drawn by the blades of bulldozers. The cultural memory of the Second World War is often dominated by images of combat. The infantryman storming a beach, the fighter pilot engaged in a dogfight, the submariner peering through a periscope. These are the dramatic, kinetic moments that define our understanding of the conflict. Yet the story of the Seabees and their bulldozers offers a different, but equally crucial, perspective. It reveals that the war was not just a series of battles, but a massive industrial and logistical contest. Victory depended as much on the ability to build, supply, and maintain a fighting force as it did on tactical brilliance or battlefield courage. The American success in the Pacific was, in large part, a triumph of engineering and organization, a victory won by men whose primary contribution was not to take life, but to shape the very earth to support the war effort. This logistical mastery created a relentless grinding pressure that the Japanese military system simply could not withstand. The Japanese strategy was predicated on the idea of a decisive battle, a single climactic engagement where the superior spirit of their warriors would crush the American fleet. They sought a repeat of the Battle of Tsushima, which had decided the Russo-Japanese War in 1905. But the Americans refused to play by these rules. Instead of seeking a single, decisive battle, they waged a war of attrition and position. The island-hopping campaign was the physical manifestation of this strategy. It was a slow, methodical advance, a step-by-step conquest of strategic locations. Each island taken and developed was a permanent gain, a fortress that could not be retaken, a stepping stone that brought American power inexorably closer to Japan. The growl of the Caterpillar D-8 was the sound of this strategy in motion. This approach also minimized American casualties in the long run. By building forward air bases, the U.S. could establish local air superiority, protecting its fleet and ground troops from Japanese attack. By constructing deep-water ports, they could ensure a steady flow of supplies, from ammunition and food to medical equipment and reinforcements. This meant that the American fighting man was, on average, better equipped, better fed, and better supported than his Japanese counterpart. The Seabees created a virtuous cycle. Better logistics enabled more effective combat power, which in turn made it easier to capture the next island and build the next base. The Japanese were trapped in a vicious cycle. Poor logistics led to weakened combat power, which resulted in the loss of bases, further degrading their ability to supply the remaining garrisons. It was a strategic death spiral from which there was no escape. In the end, the Bulldozer did not just build airfields. It built the foundation for a new type of global power projection, The Second World War was the moment the United States fully came of age as a global superpower, and its ability to mobilize its industrial might and project it across vast oceans was the key to this transformation. The network of bases the Seabees constructed across the Pacific became the backbone of America's post-war presence in Asia, a strategic footprint that endures to this day. The humble earth mover, a symbol of domestic progress and the taming of the American frontier, had been transformed into an instrument of global strategy. It proved that in the 20th century, the true measure of a nation's power was not just the size of its army, but the strength of its factories and the skill of its builders. The war in the Pacific was ultimately won by the nation that could move more dirt more quickly than its enemy. As the war drew to a close and the final, devastating blows fell upon Japan, the contribution of the Seabees and their machines took on its ultimate significance. The atomic bombs that ended the conflict were delivered by B-29 bombers, flying from the sprawling airfields of Tinian, airfields that had been conjured from sugarcane fields in a matter of months. This fact serves as a powerful and final illustration of the war's central theme. The most advanced weapon ever created by science was entirely dependent on the foundational work of the most basic and robust of machines. The path to the atomic age was, quite literally, paved by the bulldozer. Without the ability to rapidly construct these massive forward operating bases, the strategic bombing campaign against Japan, including the nuclear missions, would have been impossible. The unassuming Caterpillar D-8 was the silent, indispensable partner to the Manhattan Project. The legacy of the bulldozer in the Pacific is therefore a story of profound irony. A machine designed for creation and progress became a pivotal weapon in a war of unprecedented destruction. It represented an industrial power so overwhelming that it could build the infrastructure of victory faster than the enemy could build their defenses. It was a tangible, 12-ton symbol of the productivity gap that Japan could never hope to close. Fleet Admiral Halsey's ranking of the bulldozer as more important than any surface ship was not hyperbole. It was a clear-eyed assessment from a commander who understood that modern warfare was a contest of systems. The ships, planes, and tanks were merely the sharp edge of the blade. The industrial base, the logistical chain, and the construction battalions were the immense weight behind it, providing the force for the decisive blow. When the surrender was signed in Tokyo Bay, the men who had operated these machines were among the unsung victors. They were the carpenters, mechanics, and electricians who had traded their tool belts for military gear. They were men like Aurelio Tassoni, who saw a problem and drove his bulldozer straight at it. They were the thousands of Seabees who endured tropical diseases, enemy fire, and back-breaking labor to lay the foundations of victory. Their motto, "We build, we fight," perfectly encapsulated their unique contribution. And in the Pacific, the building was the fighting. Every runway they paved, every pier they sank, every road they carved was an act of war, an offensive maneuver that crippled the enemy's ability to resist. The Second World War was won by many factors, but among the most decisive was the simple, brutal fact that one side brought shovels to a contest of machines, a fatal miscalculation in a war that would be defined, above all, by the power of industry.